When a biological cell divides, the most critical moment is not the final result, it is the transition. To understand how the system survives, you have to watch the internal structure reorganize under tension before the split occurs. We are currently evaluating artificial intelligence by looking at the wrong object. We wait for the final text output and score the result, completely ignoring the structural drift and mechanical stress accumulating under the surface during the run. This blind spot stems from a single engineering error, the assumption that AI memory is a storage and retrieval problem. The industry believes that to make an agent smarter, you simply expand its context window and feed it more past data. This is a standard RAG architecture. It treats memory like a hoarder's hard drive. It retrieves old chat logs, summaries, and unverified outputs, stuffing them back into the active prompt based entirely on semantic proximity. If an old note sounds relevant, it gets reloaded. The result is a failure mode called transcript hell. The agent is no longer reasoning. It is dragging a massive, corrupting manual of unverified assumptions across continuous loops, with each new output contaminating the next. In this state, a single hallucination is accepted as evidence. A false shortcut becomes a permanent policy. The entire reasoning route drifts off course long before the user's dashboard ever registers a failure. Systems researcher Terrence White argues for a strict alternative. Memory needs proof. Instead of acting as a passive storage bin, an AI's memory must function as an active governance layer with rigid admission rules. Memory does not retrieve the past. It decides what the future is allowed to trust. Without admission controls, we are deploying agents that self-certify their own delusions. Biology provides a highly efficient blueprint for this. A genome does not record every event an organism experiences. It acts as an admission gate, preserving only the specific, verified structures that survived environmental stress. An AI agent completing a task is not evidence that its reasoning path should be trusted again. Success alone is highly susceptible to Goodhart's law. If you reward an agent purely for the final score, it will find fragile, brittle shortcuts to achieve that score. To prevent this, a functional memory system requires 4 specific states: candidate, inherited, questioned, and quarantined. A candidate pattern is one that worked once. It produced a useful result and survived a single run, but it is on probation. It requires independent validation before it can influence any future decisions. Only when that pattern survives repeated structural stress across varying contexts does it move to the inherited state. Even then, the trust is conditional and subject to continuous monitoring. If a pattern cannot pass an independent check outside of its original success metric, it is an assumption. When AI agents operate on unverified assumptions, those errors compound quietly in the background until the entire system collapses. To safely govern what logic enters the inherited state, the architecture requires an independent check. White defines this mechanism as the orthogonal witness. The witness ignores the text the AI generates. Instead, it performs pre-transition fingerprinting. It monitors the hidden channel of the run, measuring the physical strain on the system's logic pathway before a single word is output. The witness tracks the mathematics of coherence dynamics. The 2 primary metrics are kappa, which measures the mechanical stress on the logic pathway, and delta Hall, which measures how far the system is drifting from its core objective. There is no universal static number for kappa that signals an alarm. Applying a rigid threshold to every agent results in a twitchy dashboard that throws false positives. Instead, the threshold is dynamically calibrated against the specific system's healthy baseline, represented by kappa star. The witness calculates the exact stress ratio by dividing current stress by that calibrated baseline. If the stress ratio is below 1 and the witness holds, the memory passes the green gate and is safe to use. If the ratio climbs to 1 or higher but the system's capacity holds, the amber gate triggers. The system monitors the logic, but delays inheritance. But if the stress ratio hits 1 and the witness degrades, the red gate engages. The system drops the precedent, quarantines the specific logic block so it cannot spread, and forces the agent to return to first principles reasoning. This is where true agency exists. It does not live in retrieving old files. Agency is the power of the controller to actively decide what earns inheritance and what must be destroyed to protect the system. Without an independent witness arbitrating the friction between stress and capacity, you have not built an intelligent, adaptable agent. You have built an automated dogma machine. This rigorous admission protocol solves the scaling problem for multi-agent coordination. Decentralized agents cannot coordinate efficiently if they are forced to exchange gigabytes of raw, unverified chat transcripts. When a reasoning cluster successfully passes the witness gate, it undergoes what evolutionary biology calls a chromosomal inversion. The logic is locked together into an immutable, tightly bound unit known as a supergene. This supergene takes the exact shape of an argument graph. Instead of a block of text, it explicitly maps the causal levers of the decision into distinct nodes: point, because, but, and so. It shows what evidence supported a claim and how it survived contradiction. This entire verified graph is then compiled into a lightweight, cryptographically signed JSON receipt, utilizing the OpenLine and COL standards. Instead of dumping massive context windows onto each other, agents simply exchange these receipts. They adopt proven, stress-tested strategies instantly, preserving their compute rather than relearning basic survival mechanics from scratch. Coordination scales rapidly across trust boundaries when all independent agents can stand on a shared, mathematically verified computable floor. The enterprise market is recognizing this exact problem. Tech giants have realized the liability of agentic AI and are rushing to deploy their own governance and audit toolkits. But their approach contains a structural flaw. They are building institutional logs. The data, the error tracking, and the accountability mechanisms are trapped entirely inside their proprietary walled gardens. In the physics of system constraints, institutional logs artificially extend tau, the lag time between an AI error and the consequence. They hide the failure and shift the cost of that failure entirely onto the user. White's OpenLine protocol operates on the inverse principle: proof moves, data doesn't. Because these JSON receipts are portable and user-owned, they cross trust boundaries instantly, forcing the lag time between error and consequence to zero. If a central institution controls the memory, they control the record of events. But if the user holds the cryptographic receipt of the agent's logic, accountability remains in the market. The next conflict in artificial intelligence is not about which lab trains the smartest model. It is about who owns the verified record of its decisions when it inevitably causes harm. White's architecture sits in a phase of late pre-emergence. He holds a mathematically robust moat, but remains vulnerable to enterprise competitors co-opting his vocabulary of provenance and auditability without implementing the actual accountability controls. To counter this, he cannot wait for institutional permission. He has to bypass the credentialed gatekeepers and force the industry to respond directly to the architecture itself. This dynamic is known as the millimove. It occurs when someone completely outside the approved, well-funded class touches the future by highlighting and solving a massive technical bottleneck, forcing the room to react to the build rather than the resume. The immediate tactical execution requires releasing a frictionless, free user-facing receipt wallet, paired with a live case study that proves hard cost reductions for production agents. The established script is still loose enough for independent builders to rewrite the rules of intelligence. They just have to give the market proof it can carry in its own hands.